In this video we're going to be looking at vectors. Now vectors are a really important function both in maths and science. Particularly in physics we use vectors for showing direction of different forces and so on. So the main thing about a vector is a vector will have a particular value, so it has a size, and it also has a direction associated with it. Now, we generally have two types of values. We have scalar values and we have vector values. So scalar values are things like time, mass, height. We might even have things like speed. Right, vector quantities are things like velocity, acceleration, displacement, force, momentum, all things that you may, if you don't already know about, you may see and experience and use. Alright, so it's really important. So I try and think of this way when I explain this in physics to students is if we have a speeding train coming towards you, right, so if you're standing on the train tracks, then you're quite worried about that train coming towards you. It's going to hurt. It's going to kill you, isn't it? So the direction that that train's moving, its velocity, its momentum and all its force and so on, matters because its direction matters. You're standing 100 metres away from the track and you're looking at the train going past. You're probably looking, wow, it's a nice looking train, and it's not going to worry you that much. So the direction doesn't matter when it comes to vector quantities. Scalar quantities, it doesn't really matter that much. Alright, so scalar quantities is to do with the size of the thing over there. Now, if we're looking at some vectors here, and I've drawn a couple of vectors already in preparation. So I'm going to call this vector A. Vector A, either you draw a bold thing or you put a little arrow on top of it. Okay, a vector there. This vector down below is actually minus A. Right, it's going in opposite direction, it's got the same length as A. Alright, so if we have to label what this vector looks like, so we can do the algebraic part as well as the vectorial part, is we use square brackets. Alright, so we use square brackets to represent this, and we do our x direction and then we do our y direction. So this one goes across 2, 4, 6, 7, goes up 3, so that vector there would be 7, 3. Alright, we'll call this one here vector B. Vector B, we always go across the x direction first, so it's going to go across 4, it's going to go down 1, 2, 3, 4, 5. So vector B is going to have the size of 4, negative 5 will represent that vector there. Again, negative B goes the same length as B but in the opposite direction. Alright, we'll call this one over here C. C goes across 1, 2, 3, 4, 5, 6, and it doesn't go anywhere in the y direction, so that there is 6, 0. And again, this would be minus C, vector C. And then vector D, this one over here, right, goes 1, 2, 4, 6, 7. It goes 0 in the x direction, so it's 0, negative 7. And this one here would be negative D. Alright, so I've got my example of how you will label your vectors. So they, again, a little bit like x and y directions. Pretty simple, straightforward sort of stuff to do. Right, if I've got to do a vector addition, I'm going to go A plus B. So what I might do is do this vectorially so you can see it. So I'll just copy that and we'll paste it in. Right, so this is vector A. I'm going to do this first one, which is A plus B. Right, so if I'm doing A, it goes from there. Now I'm going to select B over here, Control and copy. It's just coming across anyway, it doesn't matter. Alright, so A plus B, this is my vector addition. So what I want you to think about is where you start and where you finish. Alright, so vectorially, what am I doing when I'm doing A plus B? In terms of me looking at my resultant vector, it goes from where I start to where I finish. So I started there and I finish here. Right, so this is in fact, when I start looking at this, this is in fact A, this is my B vector, and this vector here is A plus B. Got the idea? So I'm going across, obviously A was going across 2, 4, 6, 7. I'm going across another 1, 2, 3, 4. So I'm going across 11, that direction there. I'm going up 1, 2, 3, 4, and I'm coming down 1, 2, 3, 4, 5. So I'm going up up 3 and down 5. So that means I'm going -2 overall. Now, if you think about this vector, it goes 1, 2, 4, 6, 8, 10, 11, and down 2. That is the vector addition. Now, that's a vectorial way of doing it. You can also do it algebraically. I can do A plus B is simply going to be 7, 3. Oh, sorry, 7, 3 plus 4, -5. When I do this, all I'm going to do is add the x values together. 7 plus 4 is 11. 3 take 5 is going to give me -2. So I can either do it algebraically or I can do it vectorially. Got that here? So hopefully that makes sense. Let's do the second one here. Right, so what does 2a mean? Right, 2a means simply I don't really want to actually take that ID. So if I copy that and paste that, for some reason it won't let me copy and paste. Okay, paste that again. So 2a means simply I'm going to add two vectors together that are two lots of a. So I'm going to start there, that's 1a. That means I'm going to go 2 lots of a, gets me to that point there, and then I'm going to take c away. So this is my take c. Copy and paste. And so that's 2a plus c. I'll move that down. Oh, come on. So it's really important that you see how we're doing these things vectorially, and I'll talk about something in a second which I want you to be totally aware of. So if you're looking at our resultant vector starts from this particular point. That's where we started doing our addition from, and goes to that point there. Alright? So what has actually happened as we've done this particular thing over here? Well, as we've done this, we started from this point over here. We'll do it in red. Okay, we started at this point here, we finished at this point here. So we call it almost a start point and our finish point. So we've gone across 7, gone across another 7, gone across 14. We've come back 6. So technically, going in the x direction, we've gone across 1, 2, 4, 6, 8. So we're going across 8. So this is here is 2a, and that's take c. So this is 2a take c. So effectively we've gone 8 across in the x direction. In the y direction we've gone up 3 and up 3. So we've actually gone up 6, and we've not changed it with the c value. So my vector 2a plus take c is in fact a vector which goes across 8 and goes up 6. Right, and we can do the same thing algebraically as well. As we do there, we can go and grab our, actually we'll do it in red. Right, so 2a, so that's 2 lots of a, which is 2 lots of 7 and 3. and we're taking 6, 0. Alright, so we can do this the long way. So that's going to be 14 and 6. Take away 6 and 0. So therefore that will give me 14 take 6, which is going to give me 8. 6 take 0, which is going to give me 6. And that gives me my answer. Here what I'm looking at. Right, the next thing I'm going to want to do is I want to do this addition here. B plus D takes C. Now I can add as many vectors as I really want to. I don't have to limit myself to 1 or 2 vectors at any particular time. So let's do a B. I'll copy and paste. So that's my B. So let's do it down here. We'll give ourselves a bit of room, hopefully. Okay, so D, and then we're going to have to add on our D value. Copy and paste. Drag that down. Might need to give myself a bit more room here. Okay. So starting there, how about we go up here? We'll move that one up here. So we've got D plus, we've got B plus D, and now we're going to go take C, and take C is this one here. So we copy that and we paste it. Drag that down. Now notice what I'm doing when I'm adding these vectors together is I'm going tail, head to tail, head to tail, or tail to head, tail to head. Alright, that's what I'm doing. Now, if I'm looking for that vector addition, alright, so then simply all I'm going to do with this is going from when I started there, and I'm moving to this point here. Now I can either do it by adding the other vectors and following the path, I could just go from my start point to where I finish, and I could just simply go and add those things up there. Alright, so that's where I start, that's where I finish. Alright, so I've got my B plus my D, and that's take C. So this is simply going to be B plus D take C is my vector addition. Okay, so I'm effectively in my X direction, I'm going across 4, going down 0, coming back, how many is it, 6. So technically from here, I'm going across -2 in the X direction. Here, I'm going down to 4, 5, going down to 6, 7, so it's down 12, I'm going across, so that's going to be -12. Is that vector there. Now if I do my vector addition, I know B is in fact going to be 4, -5. My D value is in fact going to be 0, 7, square brackets, and then I've got my C value, which we know is going to be -6, 0. So when I start doing that, it goes 4 plus 0 take 6 is going to give me -2. -5 plus 7 is 2. And, sorry, that's actually -7, not 7. So -5 take 7 is going to be -12 plus 0 is -12. So my vector there is in fact -2, -12. Right, so it sort of matches the algebraic way of doing the vector addition. Alright, so key things to revisit is simply our vectors are simply how far in the X direction and the Y direction. Right, our negative vectors go in opposite direction but the same length, and we add our vectors together by simply going tail to head, and that's how we do. And so when we're looking at trying to find our resultant vector, it's from where we start to where we finish is our resultant vector that we're actually doing. Alright, so hopefully this makes sense. We'll get you to do a little bit of practice in class with these questions.